very good morning to Dr. Shamir and Madam Zanaria. We're from Group 2B presenting the mini project Solar Oven. Let me start by giving you some background information on how a solar oven works. A solar oven works by catching sunlight using a reflector and reflecting it onto a black surface. Here we use a black sheet of paper. And the black surface transforms the light into heat, and the container, which made from aluminum foil, will trap the heat inside. So it's very simple. The material we used is cardboard, aluminum foil, plastic wrap, and a sheet of black paper. The lid of cardboard will cover with a layer of aluminum foil. This will reflect sunlight into the box. We also seal the opening with plastic wrap, so this plastic window works like a greenhouse roof. It allows sunlight to pass into the box while also retaining heat. Then the box traps the heat and the oven will get hotter. There is a piece of black paper placed at the bottom of the box. Dark colors are better at absorbing heat, so that's why the inside is black. This will act as a heat sink that absorbs direct and reflected the sunlight to warm the food, which will heat up it while placing it on top of the black paper. So to cook the food, you just leave the box under the sun with a container of food inside. Then the container will sitting on top of the black paper at the bottom of the box. When sunlight enters the box through the glass top, the light waves will strike the bottom and making it become hotter. After waiting for a period of time, about 20 to 30 minutes, the food will be cooked.
Hi, Assalamualaikum. My name is Sufi binti Yaakob. My meeting number is 205. So you can see from the slide the video of the process to melt the chocolate from a bar of chocolate to a chocolate that completely melt. Hi, Assalamualaikum. My name is Sufi binti Yaakob. My meeting number is 205.
Hi, my name is Faiza Nufitra binti Hasim and my metric number is 206,438. Now I'll be explaining about the significant steps that we have done in making the solar oven. So as can be seen in the picture, we put black paper at the bottom part of the box. So why do we do that? It's because a black body has the highest emissivity, which is 0.98, as can be seen in the table. The emissivity value ranges from 0 to 1, so 0.98 is the closest one to 1. And most often, the value of emissivity is written or set to be 1. So what does it mean? So emissivity is a property of the surface of an object that determines how much energy in the form of heat is being reflected and how much is being absorbed. So emissivity is very dependent on color, and as can be seen in the table, different colors have different values of emissivity. So since a black body has the highest emissivity, that means it absorbs the entire radiation incident on it. That is why a black body is said to be a perfect absorber and a perfect emitter. This can be proven from the equation Q absorb equals to absorptivity times with Q incident. Absorptivity is denoted as alpha, which means the fraction of the radiation energy incident on the surface that is absorbed by the surface. And Q incident is the rate at which radiation is incident on the surface. So does absorptivity have anything to do with emissivity? Yes, it has. This can be proven from the Kirchhoff's law of radiation. Kirchhoff's law of radiation states that the emissivity and the absorptivity of a surface at a given temperature and wavelength are equal. So in many practical applications, the surface temperature and the temperature of the source of incident radiation are of the same order of magnitude. and the average absorptivity of a surface is taken to be equal to its average emissivity. So why do we have to place it there? It's because at the bottom part of the box is where all the heat energy is being reflected to from the aluminum foil. So the black paper will absorb direct and reflected sunlight and becoming warm and then transfer the heat to the cooking pot that is placed on top of it via conduction mode. Next, we wrap the box with aluminum foil. Why? Because we want to ensure that the rays of light can easily be reflected. So aluminum has low emissivity, which is 0.07, and comparing 0.07 to 0.98, that's a huge difference. So instead of absorbing the heat, it will reflect the heat. So aluminum foil is a perfect reflector, not a perfect absorber. Next, we put cling film at the opening part of the box. Why? Because the film works like a greenhouse roof. And the thing that is applied to a greenhouse roof is also applied to the solar oven that we make, which allows both direct and reflected sunlight to pass into the box and retains the heat that is transferred inside the box. So as heat keeps being reflected more and more inside the box, the air temperature inside the box will be higher and higher, and it stays inside the box, circulating in it. So the main purpose of this step is to decrease the chances of losing heat to the surrounding via convection mode, be it natural or forced one. Last but not least, our cooking pot is made of aluminum. Why? Because aluminum has high thermal conductivity. This can be further explained by Fourier's law, which the equation is Q, the rate of heat transfer, equals to the thermal conductivity times with the surface area times with the temperature gradient. So, as can be seen from the equation, the thermal conductivity is directly proportional to the heat transfer rate. So the higher the thermal conductivity, the higher the heat transfer rate. So the heat from the black bottom will be transferred to the cooking pot at a faster rate.
The tail of solar reflector is important because the reflector will need to reflect a maximum of sunlight energy when the sun is perpendicular to the oven. When we touch the oven, we keep changing the position of the oven, and this makes the angle of the sunlight is not consistent. So, to improve our solar oven, we need to maximize the sunlight exposure to get the best performance of the solar energy. And to do that, we need to set the angle of the reflector at the tip of 60 degrees. The second step to improve our solar oven is we can increase the optimization of the heat retention and insulation. In order to do that, besides using the aluminum foil that we wrap inside of the solar oven, we can also add a wool because it can trap heat effectively and helps keep the oven hot by preventing a heat loss. To add the wool, we can cut it to fit inside the oven and then use a pair of scissors to make a small slits in the wool to help it fit better around the solar oven walls. The final step to improve our solar oven is we should not wrap the cooking pot with a cling film. The reason is the cling film will be act as an insulator, thus trap the air around the cooking pot. This will make the cooking pot become slower to hot because the heat from the hot air inside the oven cannot conduct into the cooking pot faster.
Hi, this is Charmaine, and I'm going to talk about whether or not our solar oven worked or not and how well it worked. So, as we were able to see in the video footage, the solar oven did work, but did it work well is the question. Well, the thing is, it took us almost half an hour to melt the chocolate bar. So, in truth, while the solar oven was able to work, it is not a very efficient way of cooking things. Because, in fact, after doing some reading, we discovered that recommended duration for using a solar oven to cook anything was at least 2 to 4 hours and not only half an hour like we did. So, while yes, the solar oven did work, no, the solar oven is not a very good way of cooking something if it can't even melt the chocolate bar efficiently. It's much faster to do it in a microwave in seconds. But next, I'll be talking about why the solar oven was able to work, even though it is not very efficient in doing so. So even with not very glowing results, why was the solar oven able to work in the first place? Well, it boils down to three major factors, and that is the intensity of the sunlight and the ambient temperature, basically having the right conditions. And then next is the heat absorption and the heat retention of the materials. Basically, it depends on the build quality of the solar oven. And the third is, of course, the greenhouse effect model that the solar oven basically mimics, which is having a cling film trapping air inside the box. I will explain each of these in detail. So the most important part of using a solar oven is to make sure that you are using it under the right conditions, such as having a strong enough sunlight, having a hot enough weather, and having an angle of the sun that is most optimal for absorbing heat. So you want to make sure that you are doing it under very strong sunlight, so that you can convert more solar energy to thermal energy. You want to make sure that the air around or the environment around the solar oven is very hot, so that the solar oven will not lose heat so quickly. And thirdly, you also want the angle of the sun to be as close to 90 degrees as you can, so that you can very easily angle the solar oven so that you can reflect the rays into the box, and to also make sure that you can have maximum absorption, because absorption is dependent on the angle of the sunlight striking the objects. Other than having the right conditions for using a solar oven, you will also want to make sure that the solar oven is made with the right materials. So you want to make sure that you are using materials that can absorb heat and retain heat very well, such as the black paper that we used that were placed at the bottom of the box. So black paper, we use it as we justified in justification number 1, is because it can absorb and radiate heat very well. And at the same time, aside from the black paper, we also use aluminum foil. So by including the aluminum foil on the flap of the top, we can reflect the sunlight into the box so that more sun rays can enter the solar oven and generate more heat. So all of this ensures that the solar oven is able to trap, retain, and absorb the heat and transfer it all to the chocolate bar. Last but not least, the design of the solar oven also matters. So our solar oven was modeled like a greenhouse because we have a cling film at the top that is trapping air inside the box. So when you trap air inside a box, you are cutting off the air from the outside atmosphere. So as a result, the air inside the cling film will not be able to interact with the cooler air outside. But at the same time, heat will still be able to enter the solar oven because the top is covered by a clear plastic cling film. So just like a greenhouse, sunlight is able to enter the box, and the heat generated by the sunlight will be trapped inside because of the refraction and because of the fact that it is cut off from the outside atmosphere. So as time goes on, heat will build up and the temperature will rise inside the solar oven, and this is what enables the chocolate to melt. And like that, you can use a solar oven to cook something. And those are the 3 points as to why the solar oven works. But obviously, there are many things that we can do to improve, as Nasmi has explained earlier, because the solar oven that we made, or at least our demonstration, was not very successful, but it was successful enough to show that, in theory, a solar oven can be used to cook something. It can generate heat, it can trap heat, and it can also absorb heat. So just like a greenhouse, sunlight is able to enter the box, and the it can be used to transport that heat to the food that you put inside the solar oven. However, it is not very efficient, even though it is very eco-friendly and it is free. But as we said earlier, the solar oven is heavily dependent on having the correct conditions. So it depends on having intense sunlight. It depends on having the right angle of sunlight. Yeah, the sun has to be at the correct angle so that you can orient your solar oven properly. The temperature of the air around you has to be hot because otherwise your solar oven will lose heat faster than it gains it. So in conclusion, a solar oven can work in theory, but we do not recommend using it to cook anything. Thank you.